All right, this screencast is for the second linear programming example. Baking a tray of corn muffins takes 4 cups of milk and 3 cups of wheat flour. Baking a tray of bran muffins takes 2 cups of milk and 3 cups of wheat flour. A baker has 16 cups of milk and 15 cups of wheat flour. He makes $3 profit per tray of corn muffins, $2 profit per tray of bran muffins. How many trays of each type of muffin should the baker make to maximize his profits? So first we have to define the variables. We'll have X be corn muffins and Y be bran muffins. The first constraint, we will do cups of milk. So cups of milk and cups of milk. Corn muffins is 4 cups, so that's 4X. And then bran muffins is 2 cups, so plus 2Y. And the baker only has 16 cups of milk, so less than or equal to 16. Then we will do cups of wheat flour. So 3 cups of wheat flour for corn muffins is 3X, plus 3 cups of wheat flour for bran muffins, so 3Y. And there are 15 cups of wheat flour altogether, so less than or equal to 15. Those are our 2 constraints. And then we have the profit function. And he makes $3 per tray of corn muffin and $2 per tray of bran muffin. So the profit is equal to 3X plus 2Y. So in order to put these in the calculator, we need our 2 constraints. These 2 constraints right here need to be written in y equals form. So in order to do that, we have to subtract 4x from both sides. So we have 2y is less than or equal to 16 minus 4x, and then divide by 2. So y is less than or equal to 8 minus 2x is the first one. And then subtract 3x from both sides on this side. 3y is less than or equal to 15 minus 3x. And then divide by 3. Y is less than or equal to 5 minus x. Then in the calculator, what we can do is put them into y equals. We have 8 minus 2x and 5 minus x. And then when we push graph, those are the 2 lines, okay? Now I just graphed the lines, so we have to take a look at what the inequalities would look like. So I went ahead and changed the symbols right here to less than or equal to match what our inequalities are here. And then when we push graph, we'll see the overlap and we will see the feasible region. So I'll go ahead and outline the feasible region. It's very difficult to see. So I'm going to go ahead in and now change it to highlight the non-feasible region. Highlight the non-feasible region, I changed these signs to greater than or equal to, and it's going to highlight the non-feasible region. And I need to remember I am working only in the first quadrant. So my feasible region is this area right here. So my corner points are the x-intercepts and then the area of intersection right here. And I'll show you how to calculate the area of intersection. So first, the intercept is 1, 2, 3, 4, 0 on the x, 5 on the y. And the other intercept is 4 on the x, 0 on the y. And then we calculate the point of intersection. So that is second, calculate. We want to do the point of intersection, which is number 5. The first curve is y1. That is correct. The second curve is y2. That is correct. We want it to take a guess. And it generates the point of intersection where x is 3 and y is 2. So those are the corner points that we are going to work with. Okay, so the corner points, and then we put them into the profit function. And when we put the first corner point into the profit function, we have 3 times 0 plus 5 times 2. That equals a profit of $10. We put the second one into the profit function. We have 3 times 3 plus 2 times 2. That equals a profit of $13. When we put the last one into the profit function, we have 3 times 4 plus 2 times 0, and that is a profit of $12. So the ideal situation is that the baker makes 3 trays of corn muffins and 2 trays of bran muffins for a profit of $13.